right, practice test 26, game 3. Each of exactly 5 persons, N, O, P, and T, and V. All right, so I'm going to write those down. So we have N, O, P, T, and V. Participate in exactly one of 3 activities. Ooh, so we're going to go have some fun. So they're either going to a movie, they're going to a soccer game, or they're going to a restaurant. Right, so our activities are either they are going to a movie, they're going to a soccer game, or they're going to a restaurant. And they're doing one of 3. So that means that they're not getting, I would want to do all of them, but apparently they don't get to do all of them. All right, so now let's dive into our rules. So 1, N and O do not participate in the same activity as each other, nor does either one of them participate in the same activity as P. All right, so if we have N, that means that we do not have O, and we do not have P. And then also, if we have O, that means that we do not have N, and we do not have P. And then if we have P, that means that we do not have N, and we do not have O. That's how I would just draw them out. Just kind of knowing like, hey, these 3 cannot overlap at all. It's kind of funny because we have 3 different activities. And so clearly, like, one of them is going to be here, one of them is going to be here, one of them is going to be here. All right, rule number 2. Exactly 2 persons go to a soccer game. Awesome, so that means that we are going to have 2 right here and no more. So I'm just going to put like an asterisk there, but like, all right, we're good, we got them covered. All right, rule number 3. T and P do not participate in the same activity as each other. Well, look at P. P literally here is just like hating on everybody. So we also could draw this one out as if we have T, we don't have P. So also think about it this way. If P can't be with N, O, or T, the only person that P could be with as of this point is V. Just thinking about it positively. The only one that, not that it would have to be, they would have to be with V, it's just that they could be. All right, and then rule number 4. If N or V goes to a movie, they both go to a movie. So how I would write 4 is if N goes to a movie, then V goes to a movie. Or, and this is going both ways, if V does not go to a movie, N does not go to a movie. Or if N does not go to a movie, then V does not go to a movie. All right. So, can we make worlds for this, or do we even want to make worlds? I don't think so, because we have a lot kind of figured out. The only one that we don't really, I mean, I guess like if I were to make worlds, I wouldn't necessarily make worlds to figure everything out. I would just draw another chart quickly just to show that we're either going to have 2 in the movie space, so I'm going to put 2 here, and 1 in the restaurant, or we're going to have 1 going to a movie, 2 going to soccer, and 2 going to a restaurant. I think I would just do that just so I could easily see what my options are. All right, so let's start with number 13. Which of the following could be an accurate list of activities participated in by them respectively? Oh, and it's putting them in order here. So what this means is like N, is going to be like it would be referring to the first thing in the list. Where the second thing in the list, so O would be the second one. So when it says respectively, that's what it's referring to. I'll just do this one time just so you can kind of see. And then purple will be and then you don't have to do that on the test. I just want to show you like what they mean by respectively. All right, so so how I do it is I go back and I read my rule and I cross off. So N and O do not participate in the same activity as each other. Nor do either one of them participate with P. So I'm going to look for N is a movie. And so I'm going to make sure that N is not with P or O. And so Velez is going to the movie here. So A is okay. For B, we also have Velez going to the movie, so that's okay. In C, we have N going to a soccer game. The other person going to a soccer game is T, and that's okay. In D, we have N going to a soccer game. And we also have Tyner going to a soccer game, and that's okay. And then in E, we have N going to a soccer game, Velez going to a soccer game, and Tyner going to a soccer game. I would actually cross this one off just because I recognize that we have 3 soccer games, and we can only have 2 people going to the soccer game. So from this one, I would just cross E off. So now I'm going to check O and see if O is going with P to anything. So we already checked it for N. So O is my pink one. So soccer game. And here we have an issue in A already because we have O going to a soccer game and we have P going to a soccer game. And they can't do the same thing. So A is wrong. In B, we have O going to a restaurant. And that's the only one going to a restaurant, so that's okay. In C, we have O going to a restaurant. Same thing, cool. And then in D, we have O going to a restaurant with Velez, and that's okay. All right. All right. Rule number 2 is exactly 2 people go to a soccer game. So I just want to check all my rules and see if 2 people are going to a soccer game. It's okay in B. It's okay in C, and it's okay in D. All right, C. T and P do not participate in the same activity each other, so I'm going to look for T. So in B, T is going to a soccer game, and we have P going to a soccer game, so that doesn't work, so I'm going to cross it off. In C, we have T going to a soccer game, and we have P going to a movie, and that's okay, and the same goes for D. And then our last rule, number 4, is that if N goes or V goes to a movie, so if N or V goes to a movie, the other has to go. So, N, so we're going to see V. Here we go. So we have V going to a movie, but we don't have N going to a movie, and that's a problem. So I'm going to cross that off. And so our answer choice is going to be D. All right, number 14. If V goes to a soccer game, then each of the following could be true except. So this means that 4 of these answer choices could be true, and 1 could never be true, and that's the one we're looking for, is the one that could not happen. So if V goes to a soccer game, all right, so I'm going to go ahead in my worlds and just put a V here and a V here. So what do we know? Well, we know that if V does not go to a movie, then N does not go to a movie. So we know that this is not N in either one of these. And We know that P could only go with V if it was going to go with them to anywhere. So, okay, anyways, we'll just let that go for a second. All right, so could O go to a movie? Yeah. There's nothing keeping O from going to a movie. B, N goes to a restaurant. Could N go to a restaurant? Yeah, right now I don't see any reason why not. C, could N go to a soccer game? I think so. We have nothing constraining it. T goes to a soccer game. Or T goes to a movie. Uh-oh. I'm going to have to think deeper about this one. Could O go to a movie? All right, so it looks like I'm going to have to actually try these out. So if I put O in here, what does that mean? That would put, well, in this one, P could go here. And then we would have N and T left. And that actually works. So based on this one right here, actually, though, we can cross off A because O can go to a movie. And we can cross off B because N can go to a restaurant. So both of those could be true. All right, so now we're going to see if it can be true that N goes to a soccer game. So can we put N here? So I'm just going to try one of them. And this one over here is a little bit easier to do, rule number 2. So I'm just going to try this one first and see if N can go to a soccer game. I know that P cannot go with anything else. So I'm going to put P here. And then that leaves O and T, which I think works. Because N can't be there, P can be on its own. Yeah, so that works as well. So I don't even have to try the other world out. It can happen in one scenario, so I'm good. Okay, so let's try the next one. T goes to a soccer game. So can we have T going here? I'm going to try the less constrained one first, which actually this is a V. V, and then T. Okay, so we know N can't go to the movie, so that would mean in both of these, N would have to be in the restaurant. And then P cannot go with N, so in both of these, P would have to go in M here. And then in this first one, it would have to be O here, but that actually doesn't work because P and O can't go together, so this one doesn't work at all. And also in 2, if we were to put O here, that's funny, it spells no, and it doesn't work as well because of this first rule that N and O cannot go to the same thing. So our answer is going to be D, but we can go ahead and try out the last one just to make sure. T goes to a movie. So can T go to a movie? I'm going to put T here and T here. So we could put, in the second one, I'm just going to put P here. Oh, that won't work actually. Okay, so in this first one, I'm going to put N on its own in the restaurant. I'm going to put P with V because P is allowed to go with V. And then I'm just going to put O with T, which works. And since this scenario works, E cannot be our answer, so that leaves us with D. All right. Next one. Which of the following is a pair of persons who could go to a movie together? Well, the most that can go to a movie together is 2. And we know that if it happens to be N, then it has to be V. So any answer choice that has N or V and not the other will not work. So A, I'm going to automatically cross off. And I'm going to cross C off because V and O can't go together, because if V goes, N has to go. And now I'm just going to pay attention to, can any of these items not go together? So for example, remember, like, if we have N, we can't have O or P, or if we have O, we cannot have N or P. And so our next answer choice says O and T. I don't see anything restricting it at the moment, so I'm just going to leave it. And I'm going to go on to the next one where it says P and O. Well, if we have P, we cannot have O, so it can't be D. And the same for E, where it says if we have P, we cannot have T. So our answer can't be E, so our answer has to be B. All right, it's number 16. Each of the following statements must be false except. So this is kind of an odd question. It's saying must be false except. So 4 of our answer choices cannot happen, and 1 actually could happen. It doesn't have to happen, it just could happen, where 4 must be false. All right, so let's read these. Only O goes to a restaurant. Could that happen? So this is saying, so in this one, we would be looking at world 1. So we would put O here. And we could put, so either it would have to be N and V are going to the movie together, which would leave P and T together, which can't be together. And so this one's not going to work, because even if we put N and V going to the soccer game together, it would put P to T going to the movie together, and those just can never be together. So that one is a must be false, so it's a wrong answer. So I'm going to cross that one off. Only P goes to a restaurant. I like this one since P is really constrained and we're putting it together, but I don't know. Once again, so if N goes to the movie together, that means that V has to go. And then that leaves O and T together, which can be together. So I like this one, because even if O and T went to the movie together, it would leave N and V going to the soccer game together. So I would probably, if I was taking the test, I would select that one and move on, but we shall see. Oh, I should leave it open. All right, C, only T goes to a restaurant. All right, so if only T goes to a restaurant, once again, this leaves our, I'm just going to start making my boxes down here. So this would mean N and V are either going to the movie together, or P and O are going to this, which P and O cannot be together, so this one doesn't work. All right, for C, only V goes to a restaurant. So if we put V here, once again, well, this changes it up just a little bit. This would mean that N would have to go to the soccer game because it couldn't go to the movie without V. And then we have O, N, and P left. Well, the problem here is if we put O here, going to the movie, we can't put P going to the movie because P and O can't be together. And we can't put P going to the soccer game because N and P can't be together. So D cannot be our answer either. And then lastly, T and V go to the restaurant together. So this time I'm going to be in world number 2. I'm going to put T and V here. This means that N cannot go to the movie because if N goes to the movie, V has to go. So that means N's going to the soccer game. And when we have P and O left, well, we can't put P and S because if we do, well, we just can't have N and P together. So let's put P and going to the movie. But then our problem here is that if we put N here, we would have to put, the only one left is O, but remember we can't have N and O together, so that one doesn't work. So our answer is going to be B. All right, number 17. If N goes to the soccer game, then which of the following is a complete and accurate list of persons, any of whom could go to a movie? All right, so in our world, let's say if N goes to a soccer game, what do we automatically know? Well, we know that V cannot go to the movie. So who could be which of the following could be a complete and accurate list that are going to the movie? So remember, we only can ever have 2 or 1 person going to the movie, FYI, because we're looking for a complete and accurate list. So I automatically here would cross off D and E because I know that we can't have 3 people going to the movie. All right, so A, could we just have O? Well, before I even do that, I see B here. Anything that has V, we can cross off because V can't go to the movie without N. So we can cross B off. And so now we just have to determine if O and T can go to the movie together. So I'm just going to put O and T in here and just determine it. So if this happened, this would mean that P or V would have to go with S, and the only one that could is V. And then this would leave P going to the restaurant. And this one actually works. So our answer choice is going to be C. And the reason that it's not A is because it asks for this complete and accurate list. And A is not a complete list because it just has Olsen, which really it could also have T. So we can cross that off. All right, and then our last question. If the condition that exactly 2 people go to a soccer game is changed, okay, so it's saying we're changing this rule. So this rule that 2 people have to go to a soccer game, so I'm going to put it right here. This rule here is changed to require that exactly 3 people go to a soccer game, but all other conditions remain the same, then which of the following persons must participate in activity other than going to a soccer game? So what this is saying is like, okay, if we switch this rule to, so I'm just going to delete this for now, that instead of 2 going to a soccer game, now there needs to be 3. So M, S, R, 1, 2, 3. So then that means how many have to go to a movie? Well, 1, and 1 has to go to a restaurant because that's all we have left. And we know that if N goes to a movie, V has to go to a movie. So we know that our movie people cannot be N and they cannot be V. So this is saying, which of the following persons must participate in activity other than the soccer game? So it's saying who cannot be one of these people? I'm going to guess that it's going to be P because P cannot be with 3 people. Let's look at this. P cannot be with N, P cannot be with O, and P cannot be with T. And so if we were to put P right in here, what happens? Well, it can't be with N, and we know N can't go to the movie, so we're going to put N over here. P can't be with O, so we're just going to put O going to the movie. But then that leaves T, and there's nowhere for T to go. And so our answer choice is going to be C. If I were to trial and error one of these, what I would do is I would put, okay, so let's say other than going to a soccer game. So how you test this out is you just put it right in there. So we're going to put N into S and see, could this happen? So if we put N in there, we know O and P cannot go there. So let's put O going to the movie. Let's put P going to the restaurant. And then we have T and V, and that works. And since it works, we know that can't be our answer. And I would do that for all the other answers to test them out. And that would be how you would answer this game. I hope you found this one helpful too.